unit. First, a little housekeeping. We are in listen only mode, so please make sure your mic is muted. If you're having any Wi-Fi issues, you may want to turn off your camera and any other programs you have running. Please make note of the chat feature either in the upper right hand or lower right hand of your screen. Please use the chat for communication as we will not be taking questions by audio. Jim Kilinowski of Dewberry is monitoring the chat and will help you with any technical matters. Please be sure to post to everyone when using the chat. We are offering one continuing education credit for CFMs. To receive the credit, you must be logged in separately, answer all poll questions during the session, and provide your name and email at the end of the presentation. Poll questions should appear as a pop-up on the screen, but may appear in the chat box. If you're having issues answering the poll question, please check the chat box and use the radio buttons to respond. A copy of the presentation will be emailed to all attendees. Also, a survey link will be provided at the end of the presentation. We appreciate you completing the survey so we may improve these webinars in the future. We are recording today's session and plan to post the video on georgiadfirm.com. And with that, we'll get started. Today we have a presentation about enhancing emergency management with base level engineering. Our presenters are Megan Hanifan and Jack Krolikowski. Megan Hanifan is a licensed professional engineer and project manager at Dewberry with 9 years of experience in floodplain management, stormwater modeling, and dam safety. Over the past several years, she has also provided grant special application assistance to communities pursuing FEMA's HMGP program, BRIC, and FMA funding for flood mitigation and property acquisition projects. Jack Krolikowski is the Deputy State Hazard Mitigation Officer in Georgia, where he coordinates the Georgia Emergency Management and Homeland Security Agency hazard mitigation programs, planning, projects, and grants management work. Additionally, he serves as the co-state lead for the Georgia Silver Jackets, a collaboration between numerous state and local agencies charged with flood risk management. Jack is a graduate of Georgia Tech and lives in Atlanta with his family. And with that, I'll now turn it over to Megan and Jack.
Awesome. Thanks, Emily. All right, so I will share my screen and we can jump right into our presentation. Emily, thank you for the intros and getting us kicked off here. So today, our agenda, we are going to discuss base level engineering, an overview of what it is, and then how it can be used for emergency management purposes. And then we'll go over some resources for you and some question and answers if there's any questions. So what is base level engineering? It is a watershed-wide, cost-efficient way to develop hydrology and hydraulic modeling. It provides planning level assessments for flood-prone areas, and it can help assess what areas need additional modeling compared to the existing flood maps, help determine project scope, and also provide tools for dissemination of this information to local communities. All of the base level engineering, the BLE modeling, is done using LIDAR, so the high detail topographic LIDAR data. And it's a mix of 2D modeling in some areas and 1D modeling in other areas. Most of the BLE modeling that's been done in Georgia so far is 2D, and that's really a function of where those watersheds are. A lot of the 2D models that we've done so far are in southern Georgia, which is a lot flatter, less confined flows than other parts of the state. So 2D modeling is really more appropriate for that, for those areas. But as we continue to do BLE across the state, I'm sure there'll be other areas that are modeled as in 1D as well. And for all of the base level modeling, regardless of 1D or 2D, we are developing floodplain mapping for all of our modeled storm events, 20%, 10%, 4, 2, 1, 1% minus, 1% plus, and the 0.2%. In addition to the 1% future, and the BFE plus 1, 2, and 3 foot freeboard grids. So that is a lot of data that is available or will be available to communities in the future. So some of the goals of BLE modeling, on the FEMA side, they want to continue to build the model inventory, the modeling or the mapping that's based on models, and improve the accuracy of the modeling, as well as provide cheaper production of the modeling and quicker delivery to communities. So instead of having to wait 5+ years for communities to get this data, they get their hands on it a lot faster through the BLE process rather than the full RITS-MAP project. Looking at the Georgia goals, really focused on restudying any of the models that are based on NED data rather than LiDAR data, increasing community engagement, and giving communities the tools to help communicate risk to their residents, as well as supporting communities with their concerns or questions related to the flooding in their areas. So just to give an overview of the progress that's been taking place so far when it comes to BLE throughout the state, there are a number of watersheds that have been completed and are available on the BLE dashboard. A number of watersheds that have the engineering complete and just need to be included in the dashboard. And then a really large area of the state where BLE is in progress. So all of those blue areas will have BLE data in addition to the green areas. Okay, so these are some of the tools that are available for communities for looking at the BLE data. And this one right here, georgiadfirm.com/BLE, is the homepage to find all of them. The BLE status viewer, the playbook, as well as the dashboard can all be found on this website. And then, as Emily mentioned, a copy of this presentation will be shared, but can also be downloaded as well. So in addition to the modeling, we've also developed what we're calling the BLE playbook, which is a guide for communities to understand how to use the BLE data. And there's sections that are dedicated to floodplain management and planning and design, as well as emergency management, which is what we are here today to talk about. So with that, we'll jump right into really talking more about emergency management. And the question is, can BLE data be used to support emergency management activities? And the answer is definitely yes, absolutely. There are a number of ways that this data could be used through all phases of the emergency management lifecycle, from mitigation planning to disaster response, as well as disaster recovery. And so we'll start with talking about hazard mitigation planning. And as communities go through their hazard mitigation plan updates, there's numerous places within that update cycle where we can plug in BLE data to help those different activities. And one of the earlier steps in a hazard mitigation plan update is to review the community capabilities, understanding what tools are available to communities, what data sets are available to help inform the planning process. And so I just want to highlight here that BLE data is a new tool and a new resource that communities have at their disposal when it comes to hazard mitigation planning. The nice thing is that it can be used in addition to the FEMA effective firm products. But communities also have the flexibility to choose the more conservative product that they want to use when they're looking at hazard mitigation. So whether it's their effective FEMA firm products or the BLE data or local community products, communities have that flexibility to choose the one that's going to be more conservative and more beneficial to help reduce flood risk for their mitigation plan updates. So the image on the right is, it's actually an older screenshot of the BLE viewer. But let me see. Okay, so I want to take a break here and show you what that website looks like and how you can view and download data, the BLE data from our dashboard. So if you click the link that was included a few slides earlier, this is the website that you go to, the Georgia Base Level Engineering dashboard. It has the BLE status viewer, which shows you the progress of all the watersheds that are undergoing BLE modeling. Shows you the dashboard, which shows the results that have been posted, and then also has the playbook to help communities know how to use this BLE data. But I want to go to the dashboard. Okay, and you can see these are the studies that have been posted already. You can zoom into whatever area you're interested in. On the left, it shows all the different layers that are being shown in the map right now. If you go up here to the right, you can choose different base map. If you would prefer to see imagery, you could change that. You can also search by address if you need to zoom somewhere specific. That changes the scale. These are all the different layers that you can turn on and off. If you're interested in water surface elevation grids, the depth grids, probability grids, you can turn them all on and off here using this tool. But what I really want to show you here is the download function, which is pretty easy. All you have to do is click extract data. And then it's going to open up these options and you'll just select some sort of area of interest. I'm going to choose the square, zoom in, and let's say I'm interested in this area. I just drag it across. And output format in geodatabase is fine for me. And then I can choose all the different layers that I want to include and download and work with locally on my computer rather than working on the dashboard. So all you have to do is extract data. I won't click it because sometimes it takes a little bit of time to do that. But when you click extract data, it'll start downloading a zip file, and then you'll be able to open all of these data sets on your computer using GIS or QGIS, ArcGIS, whatever program that you use. So it's pretty simple. It's pretty easy. There's a lot of other really cool things about this. You can specifically, if you click on a structure, click. Okay. So it's going to pull up all the property specific information for this address that I clicked on. It's going to show the BLE mapping compared to the changes between the BLE and effective model. It's going to show you all the information about the firm panel, the BFEs, the lowest adjacent grade for that structure. And then it's also going to show you all of the depth of flooding and water surface elevations maximums for that building. So that's very nifty and helpful if you need to pull all of this information quickly for a specific structure. Okay. So when we're talking about hazard mitigation planning, I just want to pause here and talk about kind of the status of the different hazard mitigation plans across the state and compare that to where BLE data is available. So if you can see communities that have less than 3 months, 3 to 6 months, you can look at that and kind of compare, is BLE data available for my community and will I be able to use this in my next hazard mitigation plan update?
Yeah, I think that's a great one, Megan, too. And it's sort of interesting maybe the two groups that would be kind of this would be most relevant for, right? Would be someone who is greater than 24 months, of course, could be looking at saying, hey, for our upcoming hazard mitigation plan, we should be able to take advantage of this. Similarly, if you're somebody who is maybe less than 3 on the sort of the closer end, you're close to wrapping up, sort of you're not in a position to take advantage of it necessarily yet. But if you're sort of looking at that blue area saying, hey, by the time we turn back around roughly 2.5 years from now, when we're looking to start that update, then you're sort of in a good position there. So it's sort of either end of the spectrum. It's, I guess no perfect answer for anybody, but no terrible answer either, in the sense of kind of depending on where you are, and maybe a decent fit. So yeah, certainly a lot of coverage with that new group of blue as well. And some of those kind of that whole central sort of coastal plain area, I think we'll be able to take a lot of advantage of that. And the depth grids too, because a lot of these are coming from locations that traditionally haven't had depth data, right? They may have even had a really solid, zone A on there, that was pretty reflective of the flooding they may experience even. But it's always tough for hazard mitigation planning when they refer to it's kind of confusing. They refer to the extents, not necessarily as the sort of the horizontal extents only, but also kind of like how bad could it be kind of vertically in terms of the depth. So I think that'll be a big change for those communities too, as well as that 2D piece that you mentioned earlier, just the confidence with which hopefully they can be looking at those models and saying, yeah, that's pretty close to what we've experienced here in some of the recent events, maybe the magnitudes given by those recurring.
Yeah, for sure. I think the wealth of data that is going to be available to these communities that might not have it before is really slightly overwhelming, but also incredibly amazing, all of that data. So we're here today to help explain and talk through some of that data and make sure that it can be used to the best of its ability for these communities. Okay, so one of the next steps in hazard mitigation planning updates is conducting a risk assessment to understand a community's risks and vulnerabilities, specific to the location and magnitude of flooding, probability of flooding, and the number of ways that BLE can help identify those risks. For example, the BLE depth grids can show vulnerability and depth of flooding at critical facilities, infrastructure, and community lifelines. They can inform evacuation route planning. The depth grids can be used to estimate losses using building data and depth damage functions. And then the probability grids can also identify areas that have a higher chance of flooding more frequently. Okay, so I'm going to do another demo. And then, think about, risk assessment, trying to identify where a community's risks are. But so looking at this map, these are the shapefiles that I downloaded from the Georgia BLE viewer. We've got the 1% and 0.2% floodplains. We have our water surface elevation grids for all of our storm events. We have our depth grids for all of our storm events. We have probability grids, annual chance and chance over 30 years. And we also have ground elevation. That's something I think is really cool that you can download from the BLE viewer. If your community doesn't have LiDAR data or the latest LiDAR data, you can very easily just grab area of interest and export that if you need to get the lag of a building or something like that. It's very easy to download and use this. Really helpful for everyone. Okay, so traditionally, we've only had, or a lot of communities have only had, just the floodplain, the 1% floodplain polygon. And when you look at that, you can see there are a number of homes that are at risk, but we don't really know at what risk they are. Right now, they're all just kind of lumped into it in the floodplain or outside of the floodplain. But what communities can do with this BLE data is, instead of looking at those floodplains, we can look at the water surface elevation grids, or rather the depth grids. So we can come and see, click on a specific structure and see this has a 1.5 feet of flooding depth for the 1% storm event, where a building over here might not have that much, 0.1 feet. So you can start to use this and start to prioritize which structures are at the greatest risk of flooding. And then you can really start to focus on prioritizing mitigation solutions for those that are most at risk. Also, looking towards emergency management evacuation route planning, just as an example, this road would not be one that you would want to designate as something that is a evacuation route for people, because it's very clearly flooded, a long distance of flooding. And you can also get the depth of flooding and see how deep it is. So that's 1.7 feet of flooding across this road, which I would definitely not recommend people to drive over. We can also look at the probability grids here. So this is the annual chance probability of flooding. You can click on one of those grids, and we see that this house has a 20% chance of flooding in a given year. Again, you can use that to help rank and sort different solutions or areas that you might want to focus on. And then similarly, we also have the probability grid over 30 years, which is done because typically mortgages are 30 years, and it's really impactful communication tool for homeowners to see over 30 years, this house why it's taking so long. There's not a lot to identify here. Anyway, I know the answer. It's a 99% chance of flooding for this house right here. So that's a really powerful tool for communication to homeowners, but also, again, assessing that risk, understanding where the community's vulnerabilities are for residential structures, but also especially for critical facilities as well. All right. Okay. Here we go. Okay. All right. So after we've gone through and assessed all of our risks and identified where the communities are vulnerable, we can then move forward to develop mitigation strategies. So for an example, BLE floodplains can be used to inform more resilient development, basically where homes can be built or where homes maybe should not be built. BLE floodplains can indicate areas where you might want to look at structure acquisition and demolition, or potentially elevation. And then the depth grids can also be really helpful, as well as the water surface elevation grids, when looking to elevate or retrofit structures and know how high are we going to have to build or elevate these structures to. Let's go do a demo on that as well. These, since they seem problematic. All righty, so zoom out a little bit. So talking about, informing more resilient development and planning. Traditionally, we've only had these effective FEMA special flood hazard areas mapped, which cover this portion. And there, had been no restrictions on developing in any of this area because there's no mapped special flood hazard area. That doesn't, we we definitely know that that doesn't mean just because there's no special flood hazard area that there is no flood risk. And the depth grids and because the BLE data extends a lot further than the existing special flood hazard area, when we look at our results, we can see that there is flood risk much further beyond what's mapped on the special flood hazard area. And so communities can look at this and use this and, really recommend against building anything in these areas. The other thing that these depth grids can be really helpful for, I mentioned, were for elevating structures. And so we can turn on the water surface grid and we can turn on the ground elevation. And we can say, for example, click the structure. The ground elevation for this building is 264. The 1% water surface is 266. So we know that we have to elevate this structure at least 2 feet if we were to do an elevation project, at least 2 feet plus whatever freeboard is required by the community on top of that. So that's really good information that was not really previously available in a lot of these areas. Okay, so we've identified our risk. We have come up with mitigation strategies. And the next part is implementing those mitigation strategies to make these communities safer and more resilient. But we know one of the hurdles to implementing these, of course, is funding. But there are a lot of funding opportunities out there for communities to take advantage of, including HMGP, BRIC, and FMA. And all of those require a benefit cost analysis to make sure that they are cost beneficial, that the benefits are greater than the costs. So again, we can use BLE data to come up with those benefits cost ratios and support the development of grant applications to get these projects funded. One of the biggest ones, I think, I know Jack is very excited about this one, so I'll let him talk about that after, but using these 1% floodplains to use pre-calculated benefits for the grant applications. So rather than going through and using the full BCA toolkit to come up with the BCA, if a structure is located within the 1% floodplain, it can use pre-calculated benefits to show cost effectiveness. Some others, using depth grids to determine the depth of flooding above the lag to help come up with the benefit cost ratio, and using other software for such as HAZUS or FIA for planning or scoping purposes for those. So let's go back to, again, the map here. And I'll turn these back on.
Megan, I'm going to interrupt you for just a second. We've got a good question. Can you use this as best available data to regulate?
To regulate, like, for floodplain management purposes?
Yes.
So that there's a whole section in the BLE playbook on that, section 1, floodplain management. That is not my section, so I don't want to give you the wrong answer, but I can definitely check with our guys who worked on that.
Yeah, we have another lunch and learn brown bag that should be recorded that covered that. We can try and find the link and put that in the chat box in case somebody wants to watch it afterwards. But you can use it for zone A areas in particular. So for what it's worth.
Yeah, thank you. There's a whole, when you're looking at, is there an AE study versus an A study? So it depends on the situation that you're looking at. But the BLE playbook really breaks down all those different scenarios to say when can you use this BLE data for each of those specific situations. All right, good question. So we were talking about using these pre-calculated benefits to support grant applications. So again, in the past, none of these homes would be eligible to use pre-calculated benefits for the BCA, which basically if the value of the home is less than, I think it's $323,000 and it's in the 1% floodplain, it's automatically considered cost beneficial. You don't have to go through the whole analysis. So all of these structures previously wouldn't be able to use that sort of quick, easy button BCA check mark. But with BLE data, they can. So all of these homes, if their value was less than that threshold, would be eligible for buyouts if the homeowners were interested. Jack, I don't know if you have anything else to add on that.
Yeah, no, I mean, I think that's right. And one of the pieces that I think we tend to see, in a state that in many ways has been pretty good about kind of floodplain management regulations and higher standards, is a lot of the trouble spots we have now are kind of these localized flooding issues that just flood insurance rate maps traditionally weren't particularly good at capturing. Right, you've already today you've talked about the 2D piece in flat terrains, or here you're kind of talking more about kind of these upstream small comparative to others drainage areas, maybe part of the reason why this was not mapped originally, right? And so we have these issues either, in Metro Atlanta, it tends to be in parts that used to be unincorporated counties and are now within these city limits that kind of recently incorporated and have just had a lot of growth. And so they may not be captured again as a special flood hazard area. And so it makes it tough to work through that pre-calculated benefit piece. But here we're able to cite it as best available data. And one of the things that it avoids is this really tough situation for a local government where historically what they would have had to have done to qualify for the pre-calculated benefits would have been to map the full special flood hazard area through a flood insurance rate map update. And of course, with that comes the mandatory purchase requirement of flood insurance for anybody carrying a mortgage. So you would have had perhaps some folks saying, hey, we don't want the new flood map because the county or the state or the federal government, whomever their perspective is forcing us to buy flood insurance. You kind of avoid and sideline that part of the battle by saying, hey, we're not changing mandatory purchase requirement. We're citing this as best available data, which is completely consistent with the memorandum used to identify those pre-calculated benefits. And so there's a lot of elegance, if you will, there in terms of threading the needle between the data being available to you. Because if you look in this case, right, Megan, you've probably in that top section, you've got maybe, I don't know, 12, 15 houses. Rarely do we ever see 15 out of 15 of those homes being interested in acquisitions, right? That's just not a realistic expectation. You might have 2 or 3. And so that's where you really have that issue of 2 or 3 people benefiting from the pre-calculated benefits, everybody potentially being subject to the mandatory purchase requirement. And so to come via the base level engineering and citing that as best available data for the pre-calculated benefits is a really, I think, positive use case that we would see in our office.
Mm-hmm. Yeah, for sure. The other thing to mention, though, is that eventually it's likely that the Georgia DNR flood mapping program will move forward with taking these BLE data and modeling and mapping and moving that forward to a full risk map project update. So eventually these may be added to the firm maps, but right now they are not. So you can thread the needle, for the time being, before those, might get added officially to the special flood hazard area.
Yeah, that's a great point. That's a great point. And the timeliness, right? Because I think you mentioned earlier the timeliness of availability of base level engineering deliverables versus the full regulatory public comment period, et cetera, open houses for a full risk map, flood insurance rate map update, right? You can get this data in folks' hands a lot more quickly, and particularly with acquisitions that you're dealing with, Mrs. Smith, Ms. Jones, Mr. Lopez, right? You know, a human being for which that time piece is so like personally relevant, right? So I think there's kind of an equity piece actually there as well in terms of the service delivery that as a state government we can improve on in that timeliness.
Yeah, for sure. Okay, cool. Yeah, so awesome use of BLE data, in my opinion. So take advantage of that for sure. The other thing I want to highlight is you can, because we have all of these depth grids for all of the different frequencies, you can actually compile them and put together a whole summary basically for each of the buildings in your area of interest. Now you can do that. The BLE Viewer website does that for you on an individual per structure basis. So if you're interested in just pulling all of the depths for all the profiles for a single structure, you can go to the dashboard for that. But if you were interested in looking at your entire community, pulling together all that data, and then using that to be able to sort of sort and rank and prioritize projects within your community, you can do that using this data and using GIS. So I'll show you how to quickly do that. Let's see. We go to Analysis and Tools, and it's going to be the Zonal Statistics as Table tool. And your input raster is going to be your building data set. And then your input value raster is going to be your individual depth grids that you're looking to pull all this information for. You have to do one at a time. But then you can select maximum, and that is going to pull the maximum depth that each of these individual buildings sees for that depth grid. And then you just hit run. I'm not going to do it now. But what you get is a table that has each of your buildings and the maximum depth that each of those experience. So you might want to say for the 100-year, like we really need to look at these top 10 structures and see if we need to pursue, mitigation options for them. But you can do that for all of your different storm events as well. So I've done that. Basically, just repeat the same process and join. And you can pull that together for everything. All the storm events for all of your buildings have that data, which could be really useful for looking at depth damage functions and estimating the different damages that a structure might experience during each individual storm event. Okay. We did that. Okay, so one of the last stages in the mitigation planning portion of emergency management is, the education and outreach component. And the BLE data is a really, really great tool that can be used to inform and educate residents about the risks. And then if they know what the risks are, they'll also likely have greater buy-in and acceptance for any proposed mitigation projects that you might come up with. And it's also really helpful informing community officials and elected officials when it comes to capital improvement planning decisions. Okay, so we're going to pause based on all of our discussions that we've had so far and have a poll question for the audience. And it's a true or false question. And that is, for areas that are mapped as Zone AE with floodway, BLE data can still be used for hazard mitigation purposes. Is that true or false? And I think I'll let Jim manage the poll.
Yep, so everybody should be able to see it in the chat at the very least. If you see the options, please hit one of those radial buttons and hit submit.
Give it a couple minutes. Let me know when to give the answer, Jim.
Will do. And we'll leave it open for a few more seconds. If you have a chance, please enter the either yes or no to the poll that is in the chat. Please hit one of the radial buttons and then select enter or done. Let me see which it shows. Submit vote. All right, looks like we have the majority of people who have voted, so we're going to close the poll in just a few seconds. Okay, go ahead, Megan.
Awesome.
Thank you.
All right. So for areas that are mapped as Zone AE with floodway, yes, answer is true. BLE data can still be used for hazard mitigation purposes. As I mentioned kind of at the beginning, communities have the flexibility to choose the data set that is most conservative to support the application or hazard mitigation, planning, scoping, anything like that. BLE data can still be used even with a Zone AE with floodway. Okay, so we're really, the first part of that was talking about hazard mitigation planning. And now we'll move on to talking about disaster response and how we can use BLE data during an emergency incident to help make sound decisions during an emergency. And I know Jack has a lot of feelings about this as well, so I will let him expand if he would like to. But we can, in certain instances, use these BLE models and BLE results to simulate real storm events. So for example, we have 7 different storm events that are modeled, different rainfall depths all across a 24-hour period. So you can use that to kind of, if you know you're going to get a certain amount of rainfall, maybe within a certain amount of time, and it might be similar to a 24-hour event, you can look at those results and kind of give you a frame of reference for how it might go, how bad it might be, what's kind of your range of flooding that you might expect. It's certainly not perfect, and if you have a hydrologist or a hydraulic modeler in your emergency management office, that would really be recommended, someone who's familiar with the models, familiar with the inputs and what the outputs mean, to help you make decisions during that storm event. Of course, with someone who knows what the model means and how to interpret the rainfall and all that sort of stuff. Depth grids can be used for screening tools. If you know where the flooding is going to be, you could go out and see, if people need assistance in those areas. And depth grids can also be used to prioritize where you're staging your resources, your sandbags, your equipment, your detours, those type of things, where you're going to need them and where you definitely don't want to put them as well. So back to what I was talking about. So for example, if you're going to have, between 4 or 5 inches of rain over a 24-hour period, you might look kind of between 2 different storm event results and see, it might be similar to something like this. We know that every storm is different, so there's no guarantee that this is what is going to happen. And these are just, they're models. They're not 100% accurate to what could potentially happen out there. So I know that's why Jack, cautions against relying on these solely for decision making, but they can be used again to give you a kind of frame of reference for what might happen out there.
Yeah, I think that's a great way to put it, Megan, right? I mean, the more the more high leverage the decision is, probably the less likely you would want to go with this, certainly as the only tool, right? And particularly absent the expertise of an individual sort of running the show on it, as Megan mentioned, on the from a hydrologist or water resources engineer, something like that. But that's one of the sort of when we think of emergency management across the board, right? We have this mitigation component sort of pre-event, we have recovery post-event and moving forward. Those are comparatively lower impact use cases for which you're determining your decision making, right? Of course, the caution here in terms of the kind of the professional liability was if you don't fully understand this black box, then you need to be sort of prudent in using it, right? And so, I think that'd be the piece, right, in terms of, hey, how much confidence do we have on proposed or anticipated precipitation? Are we in a a particularly flashy basin, or are we in a comparatively flat downstream basin where most of the time our impacts, we're going to be able to understand the rainfall inland, and we're going to have 12, 15 hours as that water comes through the network before it comes to us, right? So really kind of localizing your experience to understand, if you're in, I don't know, I'm making this up as I go along, but Liberty County versus if I'm in Lumpkin County, right? Obviously in Lumpkin County, that rain's going to get on me really, really quick coming off those slopes in a different way than if I was in coastal Georgia. So not unlike any other resource, whether it's from FEMA or the state or the National Weather Service or NOAA, right? We all see that there's different models for different use cases, and they're always informative, right? But when you're in that acute sort of response phase, I would encourage sort of prudence and caution in the use.
Yep, for sure. Thanks, Jack. All right, so then moving on to recovery after a storm event. How can we use BLE data to support post-disaster recovery and make community more resilient moving forward? So looking at short-term recovery, we can use the BLE data, the mapping, the depth grids, everything we've looked at already so far today, to identify areas where we might need or want to send relevant information out to homeowners, what they need to know most immediately after the event. We can prioritize where we're sending those information resources to, using the depth grids, using the water surface or the floodplains to know, who might have been flooded. And then we can also use those same data sets to identify areas that we might need to do damage assessments on, potential debris removal, or areas where we might want to go collect high water mark information from. And then looking to more long-term resilience, we can use the floodplains to identify areas when it comes to proposed rebuilding, if something needs to be elevated or potentially relocated, if it should not be put back where it was. And it can also be helpful for estimating, establishing estimated BFEs, which might be needed to permit substantially damaged structures. Okay, so that's all we have. I'll go through some of the other resources we have. I know that Jack has to hop off if he hasn't already, so I appreciate him joining us today and providing all his GMA insight.
Thanks, Megan. Appreciate it.
Hi, Jack.
Bye.
Okay, so resources. So here's a list of a lot of the BLE information that we have, the homepage, our presentations, the status viewer, some fact sheets, and then some BLE guidance that was provided from FEMA. And then all of our other contacts and resources for the DNR and Dewberry as well. So with that, I will open it up to some questions. I think we have some time for that.
We do. So I'd appreciate everybody if you have a question to throw it in the chat so we can ask Megan that. While we wait on that, I do have a question for you.
Sure.
If the BLE depth grids are used to support benefit cost analysis, Are elevation certificates still required to be provided as supporting data?
So at the end of the day, yes. If you're using, so the question was specific to the benefit cost analysis, I guess. If you're using pre-calculated benefits, you won't have to go through that BCA toolkit process. And there are other ways to come up with the finished first floor elevation, other than an elevation certificate. But my understanding is that GEMA does require, or FEMA does require, the elevation certificates to be provided to show all the building structure information. So yes, I would say yes.
Okay. Also, I'm kind of curious. It's my understanding that the BLE areas that we are mapping are currently just the A zones. Is that correct? Okay.
Yes.
Okay.
So that's a good question and a point I forgot to make. So thanks for reminding me. But if you look at the BLE viewer, let me delete this box. All of these, it has all of the BLE floodplains and data sets mapped, but it also has this overlay, which shows the effective AE mapping. So if you were, using this for other like floodplain management purposes, you would not want to use the BLE data for these areas where there's existing zone A modeling, but it depends on what you're using it for.
Okay.
But yeah, it's really helpful to know where AE exists and where it doesn't.
Okay. Well, thank you, Megan, and of course, Jack, who had also joined us for that very informative webinar. I hope everyone now has a better understanding of using base level engineering and emergency management. We'll keep the chat open for a few more minutes so you can still submit some questions. Please be sure to include your email so that we can follow up with you. Please mark January 11th from 12 to 1 on your calendar for our next Lunch and Learn webinar. The registration link is in the screen and will appear in the chat. Please make note of the survey also in the chat and on screen. Again, we appreciate you completing the survey so that we can improve these webinars. We are offering 1 continuing education credit for today's session, available to certified floodplain managers that completed the polling questions and provide us their name and email in the chat now. A copy of the presentation will be emailed to all attendees. If you requested continuing education credits, those certificates will be emailed separately. Once more, our next Lunch and Learn is scheduled for January 11th, and the registration link is on the screen. If you missed it, don't worry, an invitation will be sent out via email. With that, thank you again for attending today's event. For those that don't have any questions, this does end our Lunch and Learn webinar. Have a great day, everybody.
Thanks, Emily.
Thank you.